Hi everybody, this is a complete walkthrough of the Chapter 2 quiz review worksheet. We're studying for the Chapter 2 quiz 1. Question 1, give the exact trig function value without a calculator of cosine 45 degrees. I'm going to start by sketching out an x and y axis. 45 degrees would start here at the initial side and rotate halfway up is 45 degrees. You can drop a perpendicular and make your triangle. If this is 45, then this other angle would also be 45. So I have a 45, 45, 90 triangle. When no other information is given and you have one of these special right triangles, you let the shortest side equal 1. And in this case, both of these sides are the same since they're both 45. So those are going to be 1. The hypotenuse of a 45, 45, 90 triangle is square root of 2. Make sure you're looking at positive sides. This goes to the right, it's positive. This goes up, it's positive. Label your x and y and r. X-axis, hypotenuse is always r, and that's the y. Okay, so now I want the cosine of 45. So the trig function values are on page 22, and remember cosine is x over r. So in this diagram, that means we're looking at 1 over the square root of 2. And don't forget to rationalize. So the cosine of 45 degrees is root 2 over 2. Example 2 is looking for the exact value of tangent of A. So this is angle A. You need to mark your opposite, mark your hypotenuse, and mark your adjacent. Go ahead and write out SOHCAHTOA to help you. So we're looking for the tangent, which is the opposite over the adjacent. So 45 over 28. You always want to reduce if possible, so I can try this out in the calculator. If I do 45 divided by 28, I hit enter and then math, enter, enter. It will tell me if it reduces, and in this case, it's already in its simplest form. So 45 over 28 is your tangent value. Question C tells you that you have a right triangle with right angle at C. Find the unknown side using the Pythagorean theorem, and then find the indicated trig function, which is sine. If you've already seen some of these questions, remember, feel free to fast forward through them. Okay, so I'm going to label what's given, side B and side C. These sides are opposite the angle. So since this is B, little b will be opposite that. If this is C, little c is opposite. And then A, little a. B equals 8, that's given. C equals 11. The first thing says to find the side length using the Pythagorean theorem. So write out your Pythagorean theorem. Next, I'm going to plug in what's given. So I am given side B, which is 8, and side C, which is 11. And write down what you're trying to find. So we're trying to find the A value. Go ahead and multiply out 8 squared and 11 squared and write that down. Next, you want to solve for A squared, so I'm going to subtract 64. If you need to use the calculator, go ahead. You can see that I got 57, which is not a perfect square. So A squared equals 57. I still need to take the square root. Technically, you get both positive and negative answers when you take a square root in an equation, but this is a side length, so we're just going to use A equals positive square root of 57. So let's label that in the picture, square root of 57. We're not done with this question though. This question is also asking you for the sine of angle B. So angle B is this angle up here at the top. So I'm going to have to think about SOHCAHTOA because again, I don't know X and Y and R, but I do know opposite hypotenuse, and I can find that information. Okay, so in relation to angle B, this side down here would be opposite. We have the hypotenuse, that's always your longest side, the one opposite the right angle, so this would be adjacent. We are looking for the sine. The sine is the opposite over the hypotenuse. So you can see that we have that information. The opposite is 8, the hypotenuse is 11, so we're going to write 8 over 11, and that would be our sine value. Question 4 is asking about the cofunction. So I'm going to write sine of 42, and then I'm going to look this up in the book because I don't remember what cofunction is. So I'm going to go to my book and look up the word cofunction. If you're looking at a hard copy of the book, the index is in the back of the book. If you're looking at the online book, it's in the index of topics. So this says the cofunctions are on page 47. Also 207, but we haven't gotten there yet, so page 47. So these are the cofunctions that I'm working with on page 47, and I'm looking for the one that says sine of some angle equals. So let's look for the one that says sine of some angle equals. It's this one. The sine of an angle is equal to cosine of 90 minus that same angle. So our angle that we're working with is 42. So I'm going to plug in 42 in place of the A. I just need to subtract now. 90 minus 42 is 48 degrees. So these are your cofunctions. Using the cofunctions, we're going to solve this equation. So these are cofunctions. Cofunctions are complementary, which means they add up to 90 degrees. So when we did these equations, what we did was we took the angles of each and we said that these two angles will add up to 90 degrees. So I'm going to write 5 theta plus 2 theta plus 4 equals 90. Once I have that done, I'm going to go ahead and combine my like terms and solve the equation. So this is just a two-step equation. So 7 theta equals 84, and divide by 7 so you can get the value of theta. And in this case, theta equals 12 degrees. So this example is asking you to find a reference angle for 480 degrees. The first issue is that this angle is too big. I'm going to need to draw a picture. So I need to find something that's coterminal. So go ahead and subtract 360. So I get 120 degrees, and I'm going to sketch out a diagram of 120 degrees to figure out the reference angle. Okay, start over here at 0. This is 90. 180 is all the way over, so somewhere here in quadrant 2. And remember what we did was we took a point somewhere on this angle and dropped a perpendicular. What we're looking for is this angle right in here, the reference angle, the one that we would use to calculate. So I rotated 120. This entire thing is 180. So I need to somehow subtract the 180 and the 120. Well, that's exactly what I'm going to do. Subtract 180 minus 120, and you will get your reference angle. So this would be your reference angle, and it would be 60 degrees. So the reference angle is 60 degrees. The next topic is grade resistance. If you don't remember how to do it, you can look it up in your notes, or you can look it up in your index and find it in the textbook. So if I go to the index here, I'm going to look up grade resistance. Grade resistance is on page 62, so I could use that page if needed to look up the formula. So I can see here that the formula we used was F equals W times sine of theta, where F is the grade resistance, W is the weight of the car, and theta is the angle. So I'm finding the grade resistance, that's the F, of a car to the nearest pound of a 2,400 pound car traveling on a negative 2.4 degree downhill grade. Okay, so 2,400 is going to go in for W. I'm going to put in the negative 2.4 for the theta, and I'm going to find the grade resistance to the nearest pound. As you're doing this question, just make sure your calculator is in degree mode. If it's not, arrow down and over, hit enter. This one is in degree mode, so I can hit clear. And I typed in 2,400 sine of negative 2.4. Make sure you're using the negative key, not the subtraction symbol. The directions say to round to the nearest the nearest pound. So if I'm looking at this number, that means this number should have no decimals after it. So think about how you would round that. If this is my decimal point here and I want to round to this digit, that means I'm looking behind and I notice that this is a 5 or up. So I'm going to round this number up. So my grade resistance should be negative 101 pounds. In this question, I'm going to find the cotangent, and I need to first find an angle that I can graph. So find an angle coterminal to this by adding 360. So I have 60 degrees, and I'm going to graph that on a coordinate plane. 60 degrees would be somewhere up here. Remember, the whole point of this, though, is that I'm drawing a triangle, so I'm going to put a point somewhere on this angle and drop a perpendicular. This is my 60 degrees. That means my other angle has to be 30, 30, 60, 90. In a 30, 60, 90, the shortest side, the one opposite 30, is always 1. The hypotenuse is double, and the other side is square root of 3. Check to see if these are positive or negative. Both of them go right and up, so those are positive. Label the sides. This is the x-axis. Label your hypotenuse, and so the other side is y. Okay, we need to find the cotangent. You may need to look at page 22 to find the trig functions, and we're looking for cotangent. Cotangent is x over y. So 1 over square root of 3, and then rationalize your answer. So the cotangent is root 3 over 3. The speed reading of a radar gun is the product of the actual speed and the cosine of the angle. So we're going to take the actual speed and the cosine of the angle, and we're going to find the product. That means multiply. Okay, so I'm going to be multiplying actual speed and the cosine of. So my actual speed of this little car here is 60 miles per hour, and my angle in this example is 20 in reference to the police officer. I'm going to be entering it into my calculator. By now I hope you're in degree mode. So I type it in, and I'm going to get 56.38 and so on. This is a speed reading, so I'm just going to round this to the nearest tenths place. So 56.4 miles per hour. And that's the speed on the radar gun. So number 10 says find the function value to 6 decimal places. So this can kind of be a clue that this is a calculator question. Before I type it into the calculator, though, I need to turn this into a decimal. So remember, there are 60 minutes in a degree, so I'm going to divide this by 60. So you can see I got 145, and this is 0.75 for my degrees. Okay, now I still have another problem here. I don't have a cosecant button on the calculator. So that means I have to either use sine, cosine, or tangent. So I went back to section 1.4 and I looked up the reciprocal identities. These are on page 29 in your textbook. The reciprocal identities say that sine and cosecant go together, cosine and secant, and tangent and cotangent. Well, we're looking at a cosecant. So a cosecant can be typed in as 1 divided by the sine of theta. So that's what I'm going to do. Okay, so I typed it in like this, 1 divided by the sine, and I'm going to round it to 6 decimal places, 6 numbers after the decimal point. And I had to round up at the end because it's 814, and then it's followed by a 5. So 776815, and then 1 point that. Okay, this is another calculator question, but this time I'm looking for the angle. So that means I need to start with the theta, and I'm going to be finding the secant, but I'm not just finding the secant, I'm going to be finding the inverse of the secant. Okay, so that's where I have the issue. So I don't have a secant button on my calculator, so I need to think about what would go in place of the secant. Well, if I look at this, I know that I'm going to be using the cosine. The cosine and secant go together, so I'm going to be using the cosine, and this is finding the angle, so I'm not just doing the regular cosine, I'm doing the inverse of the cosine. I'm going to bring this number down. Since I'm using the inverse of the cosine in my calculator, but I actually have a secant here, I need to tell the calculator that I'm doing that by putting the 1 divided by inside the parenthesis. So go ahead and type it into your calculator as you see it here. And then I'm going to hit enter, and I'm rounding to 6 decimal places. And here is my approximate value of theta. 12 is another calculator question, and you need to divide the minutes first. So I'm going to find the cosine of 41.4 and round your answer to 6 decimal places. Question 13 is another calculator question. You're trying to find theta when you are given the Trig function value, missing the angle. Remember, you're going to do the inverse of the trig function, so inverse tangent. So this is a direct calculation. I just have to hit second tangent and type in the number. I don't have to do any inverses or any reciprocals or anything, and then round your answer to 6 decimal places. And you can see what I got for theta. So finding the reference angle is just a matter of drawing a picture, but I have to find something coterminal first. So first I'm going to add 360 so that I can draw this out. Okay, so this is 90, 180, 270, so 225 would be somewhere down in this quadrant. As usual, we're going to drop a perpendicular, and what we're trying to figure out is this angle right here. That's your reference angle. Okay, so we rotated all the way around. That was 225. I need to take this part out to figure out what's left. This rotation part up here is 180 degrees. So if I subtract that out, that will give me my reference angle. And I got 45 degrees. So the reference angle is 45 degrees. This is another radar speed question. The radar speed is given by the product, which means multiplying the actual speed and the cosine of the angle. Okay, so this car is going 75 miles an hour, and it has an angle of 32 degrees. When you type this into your calculator, make sure you put the cosine in there. That's absolutely needed. And then let's round this to the 10th place. These will be multiple choice questions, so it will help you with knowing where to round. So 63.6 miles per hour. Finding this value without a calculator means I'm going to have to draw it. So first I need to find an angle that is coterminal, and then I can sketch it out on my x and y axis. So I'm graphing 45 degrees, and I'm going to drop this perpendicular so that I can make my triangle. This is a 45, 45, 90 triangle. If this is 45, the other one is. And what we learned was if there's no other given information, let your shortest side equal 1. But in this case, these are going to be the same since this is a 45, 45, 90. The hypotenuse then will be the square root of 2. So positive, positive, and this is all positive. Go ahead and label your sides. This is the x-axis. You've got your hypotenuse, and your other side would be y. We're looking for the sine. So think about what the sine is. If you need to look it up, it is in section 1.3 on page 22. And you can see sine is y over r. So 1 over the square root of 2, and then rationalize your answer. So sine of 4 over 5 is root 2 over 2. Okay, same thing here. We're going to start by sketching out a 30-degree angle and drawing that triangle. That means this angle will have to be 60. So 30, 60, 90. In a 30, 60, 90, the shortest side, if we know no other information, is 1. The hypotenuse is double, that's 2. And the other side will be square root of 3. Check to see if they go left or down. These go right and up, so these are both positive numbers. Label them. You've got the x-axis, so that's x. The hypotenuse is always r, and the other side is y. Okay, we're looking up the sine of 30. This is on page 22. The sine is y over r. That means 1 over 2. And in this case, we don't have to worry about reducing, so the sine of 30 degrees is 1/2. Another grade resistance question. We've got a car traveling at a 2.7 degree uphill grade, and it has a grade resistance of 120 pounds. What is the weight of the car? Again, if you need to look this up, you could look in your index and look up grade resistance and find the formula. Okay, so, or look in your notes. This has a 2.7 degree angle, so I'm going to put that in for the angle. So I entered my angle right there for theta, and I entered the grade resistance. Remember, that's the F, that's the force due to gravity. And I'm looking for the weight of the car. So I'm trying to get the W by itself. Take your finger and cover up the W, and you will see that what you need to do is divide by this sine of 2.7 degrees. That allows you to divide out, cancel out the sine of 2.7, and I'm going to type this into the calculator just like you see it. Okay, now I'm going to take a look at the answer, the directions. It says, what is the weight of the car to the nearest pound? So again, I'm rounding it to this place right here. This would be my nearest pound. So it would be 2,547 pounds. This will just drop off because that's not 5 or up. So 2,547 pounds. So these are cofunctions again, and in order to find the solution to a cofunction, you need to know that cofunctions are complementary. So I'm going to take this angle plus this other angle over here, and those together will add up to 90 degrees. So I'm going to add up the two angles, and they're going to equal 90, and I'm going to solve that equation. Okay, so far I added the 4 alpha and the alpha, that's 5 alpha. And then 15 plus 45 is 60. Now I'm going to solve my equation like you normally would with any old algebra equation. So I subtract 60, and then I'm going to end up dividing by 5. Alpha equals 6 degrees. I just want to remind you that you can get fractions sometimes on some of these questions. So if you do get a fraction, it does not necessarily mean you have done it incorrectly. So this is another cofunction, and if you don't remember the cofunctions or where they are, remember you can look in the index. In this index, it says that cofunctions are on page 47. So these are the cofunctions, and I'm looking for secant. So let's see. Secant of an angle equals the cosecant of 90 minus the angle. Cosecant of 90 minus the angle. I'm going to write my angle in place of the A. I'm going to subtract, and I ended up with 66.8 degrees. And these are two cofunction identities. 21 says ABC is a right triangle with right angle at C. I went ahead and labeled that. I put A and B. It doesn't matter as long as you label them. Find the unknown side length with the Pythagorean theorem and find the indicated trig function. Side A is square root of 2 and side C is 2. Let's label the sides. If this is A, then go opposite that. That's little a. If this is C, opposite this is little c, and B opposite. Just make sure you're putting them opposite of the angles. You are given side A is square root of 2, and you are given side C is 2. Okay, so let's find the missing side length, in other words, side B. Write out your Pythagorean theorem. So this is what I plugged in here. I don't want this to confuse you. All you're doing is you're taking a square root of 2 and you're multiplying it by the square root of 2. We've done these before, a bunch of them. If you take a square root of 2 times the square root of 2, it just equals 2. Remember, the reason for that is 2 times 2 is 4, and the square root of 4 just equals 2. So if you take a square root of 2 times the square root of 2, it's 2. Go ahead and figure out the rest of the equation. Solve for B. So B squared equals 2. I'm going to take the square root, and B will equal the square root of 2. So I have two sides that are the square root of 2. Label it in your picture. The other thing that you need to find for this question is cosine of B. So I need the adjacent over the hypotenuse. Let's label the sides. And this is angle B. In relation to angle B, this side over here would be opposite. Label your hypotenuse. That's always the side opposite the right angle, the longest side. And so this would be adjacent. I'm looking for the cosine. I'm looking for the adjacent over the hypotenuse. So that means our cosine is square root of 2 or root 2 over 2. And that one doesn't need to be simplified or anything. It's already in its simplest form. The last question is asking you for the exact value of the sine of A. So if you don't remember what sine is, remember you can look at page 22. It might be a good idea to make a list of these important pages so that you don't have to keep looking back and forth. But you can look them up in the index if needed. Okay, so page 22, the sine is the y over the r. So we're going to write out the y over the r, or in this case, looks like we're going to have to use SOHCAHTOA, aren't we? So in relation to angle A, label the side that is opposite, label the hypotenuse, and label the side that is adjacent. The side was opposite. Kind of went off my page there. Okay, so if I'm looking for the sine, I'm doing the opposite and the hypotenuse. So this page didn't really help this time. We just needed to use opposite and hypotenuse. So 28 and 53. If it reduces, great. If it doesn't, leave it. If you want to check it, you can always use the calculator. You just simply do 28 divided by 53. You would hit math, enter, enter. If the answer is still the same, that means it doesn't reduce, and this one is in its simplest form. So 28 over 53 is your answer. So that wraps up the Chapter 2 Quiz 1 review. Have a great day.